On today's 5 o'clock news, we are going to talk about a problem devastating the whole world: ocean acidification. Ocean acidification has exponentially been increasing over the past 200 years, and specifically over the last 50. But why is this a problem? Some may say that warming ocean temperatures makes surfing more fun, so it must be good. However, that opinion was likely formed without proper consideration to the consequences of ocean acidification. What is ocean acidification? Ocean acidification is simply a decrease in the pH that comes with an increase in the temperature of the Earth, and by proxy, the ocean. Even a 0.1% change to pH is huge, because it represents a 30% increase in acidity of the ocean, which is extremely dangerous to the species living there. This acidity poses a clear and present danger to ocean-dwelling animals in 3 specific ways. The first is an increase in ocean acidification will make it harder for organisms like coral, mollusks, and coccoliths to form their shells, which causes them to die off at higher rates or reproduce less, which causes a negative change in effect in the whole ecosystem. This is especially seen when corals go into a panic when the ocean temperature and acidity increase, causing them to release their polyps so they keep them fed, so they starve out and bleach, making coral reefs no longer habitable to many of the species that rely on them. The second is that keystone species die out. So these species that rely on the whole shelled species for food or the protection of the environment, like in coral reefs. Thirdly, if that didn't affect the ocean's population enough, with ocean acidification comes large algal blooms. These algal blooms can steal nutrient and sunlight from species living in the ocean area, as well as poison the water with harmful bacteria. Over to you, Will, for the newly proposed solution to this pressing issue.
Thank you, Keira. As you said, ocean acidification is one of the most significant environmental threats facing the world today. Even gradual shifts to renewable energy may not be enough to combat this threat, as our oceans are already absorbing millions of tons of CO2 every year. These absorptions have led to a huge accumulation of CO2 in the oceans already. According to experts, removing existing CO2 from the environment is arguably more critical than the increased use of wind and solar energy and a shift to electric vehicles. Despite pledges by the largest industries, global CO2 emissions rose in 2022 by 0.9% to a record high of 36.8 gigatons, or 36.8 trillion kilograms, according to the International Energy Agency. These processes will reduce emissions in the future, but addressing emissions that have already occurred requires the removal of CO2 from the atmosphere. The Intergovernmental Panel on Climate Change has estimated that by 2050, it will be necessary to remove 3 to 12 million tons of CO2 from the atmosphere annually to limit global warming to 1.5 degrees Celsius above pre-industrial levels. To accomplish this, most scientists are looking to the ocean. Proportionally, the ocean contains 150 times more CO2 than the air, meaning it is a more important location from which to extract CO2. The UCLA Institute of Carbon Management, ICM, recently presented a new project that seeks to employ electrochemical reactions to remove CO2 from the ocean. The project uses electrochemical reactors, patented as sea change reactors by the ICM itself. When ocean water passes through a sea change reactor, an electric current is applied to the water, which starts a chemical reaction that causes any dissolved materials, such as carbon, to change states into powder-like solids that are then left to settle on the seafloor. As an added benefit, this process naturally produces hydrogen as a byproduct of the reaction, an element widely heralded as the future of storable, carbon-free energy. The ICM has already launched 2 prototype systems in Los Angeles and Singapore, each capable of extracting more than 40 tons of CO2 per year from the ocean. However, the director of the ICM says this is not enough.
The scale of this problem is so big that we need to be doing this at the largest scale that we possibly can if we are to make a difference. Removing carbon dioxide from the water will free up our oceans to absorb more carbon dioxide in the future, but this will only work on a global scale.
Already, the startup has received substantial funding from numerous investors, including $1 million from the U.S. Department of Energy and a $21 million pledge from the Chan-Zuckerberg Initiative. Up next, what researchers are saying is the future of urban aquaponics and how it will affect your home value. Until then, I'm William Holland for the Daily Scholar. Now back to Keira in the studio.